This video presents the Tinmith-Endeavour backpack, developed jointly by the University of South Australia and the Defence Science Technology Organisation. As can be seen in this film, the backpack is currently in its A configuration, which allows it to rest easily on the ground, allowing users to configure it and to customise the backpack. Shown on the back is the plastic polycarbonate case. This is where the components are mostly mounted and is used to store and protect the equipment that we'll be taking outside for our outdoor augmented reality research. This plastic polycarbonate box is attached to a frame on the front which contains shoulder straps that attach it to the user's back. This frame is based on a breathing apparatus and is designed to carry heavy loads on the back without causing too much discomfort. As can be seen from this, the shoulder straps contain a number of cables which are used to connect up devices that are of interest to the user while they are wearing the backpack. As can be seen on the straps, we have a number of cables connecting to two USB connectors, a glove connector, an IS300 connector, a power switch with fuse, and a strap with Velcro for mounting any miscellaneous devices. The glove cable goes to a set of metallic gloves which contain wires sewn onto the tips of the fingers. Fiducial markers are mounted onto the thumb tips in order to allow the system to track the hand motion as the user is using the system. These gloves are the primary input device of the backpack and are used to control the system. On the other side of the backpack, we have a similar configuration with another two USB ports, glove port, as well as an SVGA connector which is used to connect up to a Sony Glasstron device. The Sony Glasstron takes power from the backpack and takes the video in from the laptop. The cable then moves on to a head-mounted display, which we'll show later. Also, a trackball mouse and any other devices can be attached to the USB ports to allow the user to debug the system while working outdoors. At the top is the GPS antenna for the Trimble AG132 GPS, and we have the Dell Inspiron 8100 laptop. The laptop configuration is interesting because we can swivel this out like a table in order to work on the computer while we are outside. By pressing this lever on the side of the backpack, we have the ability to lift the laptop out on the hinges that it is mounted on. By lifting the laptop up, we can then use it like a table. A metal arm folds out and attaches to the bottom of the backpack, securely supporting the laptop while it is in use. By removing the Velcro straps, the user can then access the laptop and perform work on the backpack while it is in use. In the backpack, a number of devices can be seen which are attached to the polycarbonate plastic frame which supports everything inside the case. It can be seen that there are a number of holes drilled into the back of the plane which allow us to cable tie objects to the surface. Objects such as the IS300, Trimble AG132 GPS, power supply, serial port converter, 12-volt battery, USB hubs, power converter, firewire hub, and glove controller are all attached to the back of the backpack using Velcro and cable ties. The Sony Glasstron was modified in order to use it in an outdoor AR environment. Firstly, the Sony Glasstron was attached to a welding helmet frame to supply rigidity and to allow us to connect other kinds of components. On the front of the head-mounted display, you can see that we have a small 1394 Firefly camera mounted onto the top of the head-mounted display. The metal screw here allows us to adjust the calibration of the camera in an up and down motion in order to calibrate for optical augmented reality. On the top of the helmet, we have the Intersense IS300 inertia cube, which allows us to perform orientation sensing for the system. These devices are all mounted together and a series of cables run along to the backpack and are connected to the rest of the system.